Today's lesson is about global winds and the jet stream. On the diagram on your screen, you'll notice there's a picture of the Earth and the Sun. And we are talking about weather, and what contributes to Earth's weather is the Sun. And here's why. The Sun, as it is shining here on Earth, it creates unequal heating in areas across our globe. At the North and South Pole, what happens is because the Earth is round, sunlight near these poles is spread out over a larger area, creating cold temperatures. See, the sun doesn't have direct contact year-round. It doesn't have direct contact with these poles, so they tend to be colder. If you'll notice here and here, as you move farther from the equator, sunlight becomes more spread out and weaker, creating slightly cooler air temperatures. So this is our zone right in this area. So it's kind of caught in the middle. It's not really cold like the poles, but it's not really hot either. So we have cooler air temperatures, or more comfortable. And then at the equator, where the sun is directly in line with, locations near the Earth's equator receive direct high-angle sunlight, which creates warmer air temperatures. So you can kind of envision like the sun as being like a giant blowtorch, and the area that's directly connecting in front of it is going to receive most of that heat, whereas the areas that are a little bit further away, being the poles, aren't going to receive as much of that intense heat. Now, the effect of the sun on our atmosphere is something we've already discussed, but we'll review it here just for a moment. Our sun is going to cause the air to rise when it is warmed, and as that air gets cooler, it's going to cause it to sink. And so that's what creates our winds. So without the sun, there wouldn't be any wind, and we wouldn't have any weather actually. Now, another effect of our sun, aside from causing winds, is what it does in terms of heating our Earth. And you'll notice that it says solar energy from the sun passes through our atmosphere. Our atmosphere is going to reflect some of that energy back, but a lot of it actually comes through our atmosphere. And that's good for us because it keeps our Earth nice and warm, as opposed to some of the other planets that lack an atmosphere. They're either super hot or they're very, very cold. Our atmosphere kind of keeps us right in the middle. It keeps us cushioned. You also notice that it says that Earth's surface itself will release some of that heat from the sun, and it radiates that back out toward the space. So Earth actually loses some of its heat as well. But what keeps some of that heat in is also our atmosphere. And notice the title of this screen says greenhouse effect. What that is where the gases in our atmosphere, which we call greenhouse gases, like carbon dioxide and water vapor, those greenhouse gases will trap that heat in our atmosphere, and that keeps us warm. So between the sun giving us that solar energy and the atmosphere trapping some of that energy, it keeps us nice and warm and makes life possible on Earth. Now, in the first slide, we looked at the different angles that the solar radiation hits the Earth. And it does change the temperatures of those areas. And so we're going to give those a little bit of a name. These are called convection areas or convection zones. And you'll notice that there are degrees latitude here. So we need to know these ranges for these different heated zones. Well, the hottest zone is, of course, at the equator. And we call this the tropical region, and it extends from 0 degrees latitude, which is the equator, to 30 degrees in latitude. And you'll notice that that is true for the northern hemisphere as well as the southern hemisphere. So from 0 degrees to 30 degrees north, then that's going to be tropical. 0 to 30 degrees south, that's also tropical. But we're just going to be concerned with the northern hemisphere for now. The temperate region is where we live, and this is where it's not too hot, not too cold, and it extends from the 30 degrees to the 60 degrees north in latitude. So that's the temperate region. And then the coldest region, which is getting the least amount of solar energy year-round, is called the polar region, and it extends from 60 degrees north to 90 degrees north. You'll also notice that there's some other types of phenomena on our globe, and that is something called the jet streams. And jet streams are an extremely fast-moving ribbon of air that can go maybe a couple of 100 miles an hour, maybe 100 miles an hour, maybe a couple of 100 miles an hour, that move across our globe. And you'll notice that bordering the northern region of the United States and the southern region of the United States are two different jet streams. The one on our northern border, right between Canada and the U.S., is called the polar jet stream. And when it dips into our area, it actually brings a lot colder weather. And a lot of that we've been experiencing recently. And then to our south, bordering Mexico and the U.S., is the subtropical jet. And when that moves into our area, we tend to have warmer temperatures. Now, we know that the sun is responsible for heating up our Earth, and we had discussed that around the equator that it heats up the most. So we would expect that all of the air that's warmed at the equator would rise and go toward the poles, and then likewise that cold air at the poles would then just sink straight down to the equator, and we would see one giant convection circle. But in actuality, that's not what happens. In actuality, we actually have several convection cells that extend across our globe. So let's just focus on the northern hemisphere. We have 3 different convection cells that occur. We have trade winds that move from east to west, and we'll talk about why these arrows curve in a separate video. And there's warm air that rises and then cold air that sinks. Even though these are warm, there's still different degrees of warm. You've got really super hot that rises, and then slightly warmer that's going to sink, so a smaller convection cell. You'll also notice in the westerlies, and this is where the United States is, and primarily what affects our weather, is the westerlies. And we have another convection cell that occurs here. Warm air rises, that cold air sinks. And these are called the westerlies because these are winds that blow from the west to the east. This also explains why most of the weather systems, most of the fronts, will move westerly. And that is because these are the winds that we primarily get. And by the way, the jet stream that affects our areas, the polar jet and the subtropical jet, they move westerly, which kind of pushes our fronts from the west toward the east. So we call these the westerlies where we live. And then we have what's called the polar easterlies. If you'll see these light blue arrows here, they're called easterlies because they're moving from the east and they're super cold. So we call those polar easterlies. So these are what we call the global winds because these are the winds that affect our globe on a very large scale. And on a small scale, we call these our local winds. We have what's called the sea breeze and the land breeze. So these are local and these are global. So there's 2 different types of winds that affect us. Now, with the sea breeze, that is where we have, and being in Myrtle Beach, we can appreciate this. Sea breezes, they come from the ocean, they come from the sea. And let's kind of go through the diagram and explain why we have sea breezes. Well, and let's pretend that this is the sand at the beach. It'll help our explanation a little bit. Well, during the daytime in the summer, the sand heats up a whole lot quicker than does the water. And you know that if you've ever forgotten your flip-flops on a summer day, you know that that sand is way hotter than the ocean. Well, because this is hot, the sand is hot, it heats the air above it and makes it hot as well and produces an area of low pressure. Remember, low is spelled L-O-W, and the W reminds you that lows have warm air. Now let's go over to number 2. In number 2, we said that this air over, the ocean is cooler, which means that the air above it will be cooler, which produces high pressure. Now what happens is that this high pressure air is going to move toward, and this is number 2 here, it's going to move toward an area of low pressure. And what happens, you'll notice, is that a front is created where this cold air is going to win. This cold air is literally going to push this warm air up with an uppercut. It's going to push it high up into the atmosphere. Now, once it gets there, in the atmosphere, that warm air that used to be warm is going to start cooling off because the upper altitudes are cold. And then, just like we had said before, high pressure always goes toward low pressure. So high to low, high to low. And so at step number 5, that high pressure air in the atmosphere is going to move toward low pressure. And this air is going to then start sinking. And as it sinks, it's then going to move toward the land. Now, it's called a sea breeze because this high pressure air that's coming in off the ocean is coming toward the land. So we call it a sea breeze because it's coming from the sea. So just remember, during the day, we have a sea breeze. Now at night, we have the exact opposite situation. At night, we have what's called a land breeze. And the way you can remember that land breezes happen at night is to remember the N in land also stands for night. Now, this is the sand at the beach, and we know at nighttime that that sand is really cool, and we don't even need our flip-flops. And what happens is, and the reason this happens is because during the day the sand heats up quickly, but at night it also cools down quickly. So it takes all day for the solar energy to warm up this water, so that at night it has that warmth that it gained during the day, so it's retained it. So water takes a long time to heat up, but it also takes a long time to cool down. So at night, the land is colder than the water. So now what we notice is that high pressure forms over the land because the land is cold, it makes the air cold, and that high pressure air is going to go toward the low. It always goes from high to low, high to low. So this high pressure air is going to have a cold front. It's making a cold front here because this cold air is going to swoop out and push that warm air up. That air is going to become colder, and what's going to happen is it goes from high to low, and what's going to happen is it's going to sink and then create a convection cell where we have this cold air is sinking, warm air is rising. Now, as this air swoops out from the land toward the ocean, we're going to call this a land breeze because the breeze is actually coming from the land out over the ocean. So those are some local types of winds that occur. Now, we want to go back and kind of touch just very quickly on the different convection cells again. Again, we want to realize that there's not just one giant convection cell where at the equator the warm air rises and cold air sinks. We now know that doesn't happen. We have individual convection cells. Now here they call them Hadley cells, but we just need to know these are called convection cells. Well, the warm air is rising in the atmosphere and the cold air is sinking. So this is just a different way of looking at it. So warm air rises up. Now this is in latitude. Well, actually just going straight up in the atmosphere. It rises and then sinks back toward the ground. Rises, sinks back toward the ground. All right, another thing that the sun affects is not only our winds but also our oceans. So you'll notice that we have the Gulf Stream here, that water is warm, and so that warm water also will rise and try to go toward the poles. And then as it is at the poles and cools off, then that cold water will sink. So convection happens with water and with land. And that Gulf Stream actually keeps us quite warm. So that warm water also heats the air. In California, they have a different effect. This cold water from the North Pole is sinking here. And so California actually has colder temperatures than we do in South Carolina. The surfers here in California have to wear wetsuits because that water temperature is so cold because of the California current, whereas our surfers in South Carolina really don't need it because the Gulf Stream keeps us warm. All right, so now we know that the sun affects air on a global scale, on a local scale, and it affects our oceans.